All right, this is the Algebra 2, Unit 7, Lesson 5 video over fractional exponents. So fractional exponents are a concept that basically takes the concepts of powers and roots and combines them into a single expression. So instead of having to have a separate expression or a separate way of writing things when you're doing like the cube root and when you're doing like something raised to a power, we're going to have one way of expressing multiple of these ideas at once. So we're not just going to have different ways. We're actually going to express them using what we call fractional exponents. And so really all a fractional exponent is the following. It's that you have a fraction as a power, and within that, the numbers on the top and bottom of that fraction tell you different things. So the top tells me the power, and the bottom tells me the root. So this could be written as the following. Instead of writing it this way, I could also express this as the second root or the square root of x to the 3. So these two expressions are interchangeable, but the first one is what we're talking about when we talk about fractional exponents. So the top is the power, the bottom is the root. Let's look at another example. Let's say I have 4 to the 3 over 4 power. Actually, we'll do 3 over 2 power. So what would this mean? Well, this would mean that we have 4, and we'd have the square root of 4 to the third. And so we could use that to simplify. We could say, well, that's the square root of 64, which in this case is 8. Say I had x to the 5/3 power. Well, that would be a root of 3 and a power of 5, so it would be rewritten this way. Power of 5, root of 3. And so that would be the way we'd express that. So these are interchangeable. For instance, if you get an expression given to you and it says something like a to the 7th root 4, I'm going to rewrite that as a to the 7 over 4 because the power is the 7 and the root is the 4. So you need to be able to do that. You need to be able to switch back and forth between them. And then you need to be able to use fractional exponents to simplify like we did here. So let's look at some examples of what this looks like and how this plays out in practice. So what we're going to be doing actually is we're going to be taking some of the exponent rules we already know, and I'll post a guide for that in the classroom resources if you don't remember those rules, but we're going to apply them using fractional exponents. So I'm just going to work through these problems. These problems are modeled on the ones that are in the lesson. So looking here, I have a to the 3rd, b to the 9th, all raised to 1/3. Now remember, in exponents, when numbers are being multiplied and raised to an exponent, I basically distribute that exponent to both. So really I could write this as a to the 3 times 1/3, b to the 9 times 1/3. Obviously, I could continue simplifying. That would be a to the 1st because the 3's are going to cancel. And then b to the 9 over 3, which is 3. And so this would be the final answer. So really, I'm just multiplying those exponent numbers. Feel free to use a calculator if you need to. You just do 3 times 1/3, 9 times 1/3, and then you get your exponent answers there. So most of this lesson is going to be doing these types of things. Here's another example right here. So I'll use the fraction for this one, or I'll use the calculator for this one. So let's go open up Desmos, and let's work this out using our calculator. So x to the 3/4. So this 40 is going to get distributed to all 3 of those. So we'll do 40 times 3/4. 40 times 3/4 is 30. So then it's going to be x to the 30th. And then 1/5 times 40 40 times 1/5. I'm just multiplying the exponents. That's going to be 8. So that's going to be y to the 8th. And then 1/2, that one's easy. That's going to be z to the 20th power, because 1/2 of 40 is 20. And that would be the final answer. So again, all I'm doing is just applying the exponent rules in a new way. More of the same. I need to multiply these two. But if we write this out, you'll see it's 2/5 times 5/8. So that's going to be m raised to, and then we can see here that the 5s are going to cancel, leaving me with m to the 2 over 8, which reduces further to m to the 1 over 4th. So that would be a good answer, but we also know this could be written as the 4th root of m. Now, I'm not sure what the problem is going to ask for the answer to look like, but that's kind of the process there. So we're just multiplying the fractions, we're getting it reduced, and then we're converting it to a root form if we need to. This one looks really complicated at first, but it isn't. We know that we're going to multiply the 4 times the 3/4, and then we're going to multiply that times each of the powers. We know there's a power of 1 on this b already assumed. So really this looks like this. A to the 1/3 times 3/4 times 4. So we can just multiply those, but I can already see right here we're going to have some canceling. 3s are going to cancel, 4s are going to cancel. So actually, we're going to get a to the 1st. And then if I do the b, also, let's go ahead and do b. b to the 1st times 3/4 times 4. Again, I can see here that my 4s are going to cancel, leaving me with b to the 3rd power. All right. Now they're going to mix in some values where we have whole numbers that we're multiplying, not just variables. So we're going to distribute this 3/2 to each term. It's going to be 9 to the 3/2, x to the 3/2, and y to the 2 times 3/2. So let's go ahead and do the things that are really simple. We know these 2's are going to cancel out. We're going to do 9 to the 3/2 power, and you can do this easily in Desmos. You're going to do 9 raised to, and that's going to be this button you see I'm hovering on right here, a to the b. So you're going to give it the a, and then you're going to tell it to do it to a certain power, and we're going to do 3 over 2. I just type that in by doing 3 divided by 2. Go back and show you that. 9 raised to 3 divided by 2, and it's 27. So that's easy. So 27 x to the 3/2, nothing to simplify there, y to the 3rd. All right, let's keep going. Oh, and that's the end, I think. Yes, it is. All right, so those examples should match pretty well the stuff that you're seeing in the lesson. So I basically tried to mimic these in the ones that I've given you. So do your best on those, and then you have some review questions. If you need help with those, please reach out to me. And I will help you out with those.